Okay, everyone. So I've been taking notes all morning on 5.3 to try and make this more understandable than, or the most understandable that I can via this, and not being able to show you examples has proved quite challenging. So I'm going to start sharing my screen, and I don't know if y'all really want me to talk over my notes I've made or not. So we're just going to go with that. So I have been making these notes in my hope that this will be the easiest to understand way as possible. And there's 4 pages of them. So yay. The vertical asymptote should be pretty simple because pretty much if you have something that can't be in the domain, that's a vertical asymptote because it's never going to equal that. Also, while we're talking about asymptotes, asymptotes are on a graph and it's usually a line that it cannot touch or cross. There are some where it can. So I have this and a few examples, but you'll get them in when we're doing our examples. And there's horizontal and oblique asymptotes. And the big thing on this is you can have one or the other. You can't have both a horizontal and an oblique asymptote on a rational function. So on ours, if you have a horizontal, there's no oblique. If you have an oblique asymptote, there's no horizontal. And then how they made these rules, they used m as the denominator. So on all these, just know that numerator, denominator, numerator, denominator. And we're always looking at the degree of the exponents on this. This page right here is going to be your guide. You are going to need this page to be able to do this homework. And then I did examples of using them because you're going to have to use synthetic division. You're going to have to recall how to factor a cube, a bunch of good things. And I'm going to upload the cube paper as well. So yellow papers, you're going to need them. So when we start off with this lesson, find the domain of the rational function. So remember that our domain is all real numbers except when it's undefined, if there's a square root, da 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 da. So right here we have x plus 5 equals 0. We want to find out what's going to make this be 0. So we'd have x equals -5. And so our domain is x cannot equal -5 because at -5 this would be undefined, so on. Find the domain of the following rational functions. So same thing here, except we have 2. So we're kind of doing the opposite of our zeros in the first one. So they give us the equation and we find what makes it a 0. And then this one, x plus. So we have 4 and -6 on this, and it's x cannot equal 4 and -6. I've seen it on that they've let me type it like this, but if you look at the example, they do x cannot equal 4 and x cannot equal -6. So they do both of them. So just be aware of that. Right here, this is one of our cubes. So what cubed equals 27? And that paper is going to be posted. And it's 3. And -3, but if we had, so 3 cubed, 3 times 3 times 3 equals 27. 27 subtract 27 equals 0. So we have x cannot equal 3. But if we had -3 times -3 times -3, this would have been +9 times -3, which would have been -27, and -27 subtract 27 is -54. So just +3 on that one. Okay, all the parts to the problem. Use the graph shown to find the following: the domain and range of the function, the intercepts, if any, horizontal asymptotes, vertical asymptotes, and oblique asymptotes. So the domain, looking at this, remember domain x, range is y. So our domain x cannot equal -2. And they have the little x here to help remind you. Big thing on this one, the range y. So it's y cannot equal. And then that asymptote right there is that 1, 2, 3. So -3. X intercepts. So where does it cross the x axis? We have it right here. So our x intercept would be 0. And they said integer. So y intercepts. So our y intercept is the same, and it would be at 0. Horizontal asymptote, so horizontal line. Our horizontal line is at -3. So on this one, our horizontal asymptote would be y equals -3. And do they give us options? Oh yeah, right here, y equals, so just put -3. And then vertical asymptotes, so vertical is this one, and it's at x. This would be x equals -2. And then on oblique, you can't have a horizontal and an oblique, so there's none. One or the other. And just so oblique's going to be like our linear equation lines. So we have x equals -2 here, and then oblique, which is the only one that showed up on this one. Oblique, there's none. Let's go ahead and get 5 knocked out, and then I'll start a different video. Use the graph shown to find the following: the domain and range of the function, the intercepts, horizontal, vertical, oblique. So looking at our deal right here, we don't have a horizontal, we have an oblique this time. So horizontal is none. Then we'll have our oblique. So our vertical asymptote, our up and down, is at x equals 0. So our domain, though, is x cannot equal 0. Our range, there's no restrictions. There's not a horizontal, or there's not a horizontal asymptote. So our range is all real numbers because there's nothing stopping it from all the up and down. Find the x-intercept, so we cross at -2 and 2. So they want them as integers, not as ordered pairs, so -2 and 2. Y-intercepts, so we have this asymptote here, so we're going to assume there's not, so there are no y-intercepts because it doesn't show it crossing, so none. Horizontal asymptotes, we already said there are none of those because there's no left and right. Vertical was at x equals 0, and then our oblique. So on our oblique line, they give us a point that's on it, and we're going to write this line just like we would our oblique, but they use a right here instead because it's going to be a linear equation line. So we're going through 0, 0, so our y-intercept is 0. Our slope, though, rise over run, so we're going to have our y over our x. And this is solving this. I'm going to y over x. -8 divided by 2 would be -4, so our oblique asymptote is -4x. That's going to, just remember when you're doing it, you're writing the equation of that line. So let's what is the domain? So we have x cannot equal -3 and x cannot equal 3. So x cannot equal -3 or 3. The range on this one's funky because it's not just this line, because there's no y values in that area right there. I don't know if it's just me, am I not seeing eyes, or if it looks super blurry to y'all too. So but so we have all the values below, so we have y is less than -2 because it's everything below -2. But then we have this gap right here, and it picks back up at -1. So then our other one is y is greater than or equal to -1. So writing that again. And they want you to use a comma, not the and sign. Because I missed it the first time I did it because I used the little intersect, not the intersect, the and it did not like me. All right, x-intercepts, we cross at -2 and 2. So then y-intercepts, it crosses right there at -1. You can't see me writing it, but -1. Fix my papers. My messed up calendar because nothing's normal now. A horizontal asymptote, so left to right, we cross at -2, so that would be y equals -2. Vertical asymptote, we have 2 of them, so we have x equals -3, and I think it lets you do that, -3 and 3. Oblique, we had horizontal, so there's no oblique. Put none, not no. Let's stop this video and start another one. Stop share.